In this unit, we're going to be studying number sense. In this lesson, we're going to look at the multiplication and division of rational numbers, or fractions. Okay, hi everybody. So in this lesson, we're going to look at multiplication and division of rational numbers, or fractions, okay? Now, remember that you do not have to have the same denominator in order to multiply or divide fractions. Not for this operation. If this was addition or subtraction, yes you would. But not with multiplication or division. You do not need a common denominator. Okay? And remember that the best way to multiply or divide is to change the fraction to an improper format. So if I've got a mixed numeral out there, or a mixed fraction I should say, I'm going to convert that into an improper fraction first before I perform the operations of multiplication or division. Now, here we go. When multiplying fractions here, you only multiply the numerators with the numerators and denominators with the denominators. Okay? And we're going to ensure that your final answer is in simplified or reduced form. We always want to simplify at the end here. But basically what this means is this. If I've got A over B, so some number over another, and I multiply it by, let's say, C over D, I am going to get A multiplied by C divided by, or over, B multiplied by D. That's how that works. We multiply numerator by numerator, denominator by denominator. Now, just to be clear, if I have, for example, a number multiplied by B over C, let's say I have a number multiplied like A here multiplied by B over C, like 5 multiplied by 2/3. And this is going to become an issue when we get further on in this particular lesson. Notice that I can always write a number as a fraction over 1. So 5, for example, could be written as 5 over 1. So this becomes A times B over 1 times C, which is just C. Okay? Now, the reason I say that is because I sometimes see people do something like this. Like, let's just say, we'll go off to the side here. Let's talk about that. Let's say I had 5 multiplied by 2/3. I will sometimes see people multiply 5 by 2, then 5 by 3. They distribute that, and that's not the way that works. Okay? This is like 5 over 1, and then I get 5 times 2 is 10, over 1 times 3 is 3. The answer here should be 10/3. So, we, again, fraction multiplied by fraction, we simply multiply numerators together, denominators together. If I get a number multiplied by a fraction, I'm going to write that as a fraction over 1, and then numerator to numerator, denominator to denominator. Let's take a look at some examples. Okay, so in our examples here, this first one we're going to multiply 2/7 by 1/6. And that's okay. So I'm going to draw my line across here because I know I'm going to get a fraction as a result. And I'm going to have 2 multiplied by 1. I use the dot for multiplication. And then down here, 7 multiplied by 6. 2 times 1 is 2. 7 multiplied by 6 is 42. So I get 2 over 42. Now, but I know that 42 is a multiple of 2. This is going to be 2 multiplied by, and if I divide that out, 21. And then 2 divided by 2, remember that's a 1. When we say it cancels, I mean that it becomes 1. Not 0, it becomes 1. So this is going to end up being 1 divided by 21. I could even think of it as 1 multiplied by 21 in the denominator, if that kind of gives you some clarity on what's going on there, but that's still just going to be 21. Over here, I get negative 3/5 multiplied by, I got 1 and 3/12. Well, I'm not hugely fond of that, so what I'm going to do here is I'm going to multiply and convert this into an improper fraction. So 1 times 12 is 12, plus 3 is going to be 15. Whoops, not 15/3, 15/12. Okay, now I'm going to multiply the numerators together. So negative 3 times 15 over 5 times 12. And there's going to be some of you here that we're going to say that wouldn't it be easier to simplify kind of as we go here? And yeah, it would be. There are ways that I can kind of shortcut the simplifying process here. But for right now, that's not our goal. Our goal is to try to understand how to do multiplication of fractions. So we're going to worry about simplifying as a separate step. Negative 3 times 15 is going to be negative 45. 5 times 12 is going to be 60. Now, after playing with this a little bit, I'm going to notice that there's a common 5 to both of those, and actually there's a common, quite honestly, 15. So this is going to be negative 3 times 15 over, what is that? That's going to be 4 times 15. The 15s will cancel. It's like 1 over 1, and I'm going to be left with negative 3 quarters. Okay? Over here, similar sort of thing, 12 20ths. I'm going to multiply that by, well, I'm going to convert this to an improper fraction. 1 times 4 is 4, plus 1 is 5. We're going to create a fraction. We're going to multiply the numerators together, multiply the denominators together. Now, I'm going to do a little bit of a shortcut here. I'm going to show you how we might shortcut this a little bit. Okay, so now that we've kind of gone through and we've done the multiplication, we've done a little bit of multiplication and then simplifying. Now I'm going to show you just really, really subtly here how we can maybe shortcut this a little bit. I know that in my numerator I'm going to have 12 multiplied by 5, but I also know that 12 is 3 times 4. And I know that 20, okay, I know that 20 is going to be 4 times 5. Okay? Now, anytime I've got a factor in the numerator that's shared with one in the denominator, that's like creating a 1. So 4 divided by 4 is 1 over 1. 5 divided by 5 is 1 over 1. So that's going to leave me with, in essence here, 3 times 1 over 1 times 1 times 4, or 3 over 4. Okay? Again, and the reason why I'm writing out the ones here is because I do notice that every once in a while people will think of this canceling as producing zeros, and I want to make sure that that's not what you're doing with that. So multiply the numerator together, multiply the denominators together, and then simplify. And if you see how you can simplify before, if you can cancel factors out, then do so. And so that all you're left with doing here is multiplying the remaining factors by the ones that you produce. Okay, in this section we're going to take a look at dividing fractions, and this one is a little bit more complicated. And I'm going to try to explain not only what to do, but why we do it, and I hope that it helps. But if it doesn't, I really want you just to focus on how we do this. So we know that 6 divided by 2 is 3, okay, because there are two groups of 3 and 6. So what is 6 divided by half? Now, notice what it says here. It says divided by half. Now, 6 divided in half is 3. Okay, that is the same as taking 6 dividing by 2. We know that that's going to be 3. So I want you to make sure that there's a difference between dividing in half and dividing by half. Okay, dividing by half is a different thing altogether. And in fact, what we're saying here, like it says here, is I've got two groups. So 6 divided into 2 groups is 3 per group. If I take 6 and I'm dividing it like half, is telling me the number of groups that I've got. So down here, this is 2 groups. Of the 6 objects, I've got 2 groups. My 6 objects is only half of a group. Well, now hold on a second. If 6 is only half of a group, then that must mean there are twice as many objects in the one group. In other words, this becomes 12. Okay? Now, so that's what we do here, remember, is that we take division, okay, when we're dividing by a fraction, we take and multiply by the reciprocal. So 6 divided by 12 means the same thing as 6, completely sidestepped the fraction here. 6 divided by 1/2 is the same as 6 multiplied by 2 over 1. In which case I would write that as 6 over 1, and this becomes 6 times 2 is over 1, which would just be 12 over 1, or just 12. You multiply by the reciprocal. Okay, so that's the step here. We're gonna convert division into multiplication. So that's what we do. So again, and there's two different ways of thinking about this. So the numerator here tells us how many little objects that I have. The denominator tells us how many sets there are. What's on this side here is how many objects are in that set. So 6 objects, 1, 2, 3, 4, 5, 6, split up into 2 groups means I've got 3 in each group. Or I've got 6 divided by or divided into half a group. So those 6 objects are actually half of a group. 1, 2, 3, 4, 5, 6. So if this is just half of a group, I'm going to need 1, 2, 3, 4, 5, 6 more, okay, to get the full group. And there's my 12. Now, if you don't like that, if that doesn't really help you, there is another way it can help you think about this. Let's say, for example, let's go back to the 6 divided by 2 is 3. So 6 divided by 2 is equal to 3. Now, what I want you to remember here or notice is that I've got this 3 as this whole number on the right-hand side, but I can always write that as a fraction by writing it over 1. Okay? I can always write that as a fraction by multiplying it over 1. So let's let that be our guiding principle here. That what I want is I want the denominator here to be equal to 1. So now I'm going to take, let's say 2/3, and I'm going to divide this by, I don't know, let's say 5/7. We're just going to pick some numbers here. So I'm going to rewrite this as 2/3 divided by 5/7. Now, what I would like, just like it happened up here, my denominator became 1. I would like this denominator here to actually become 1. And I would be happy that I've done the division if that's equal to 1 here. So what I'm going to do here is I'm going to multiply this. I got to think, what can I do? I'm going to multiply this by something that's going to make it equal to 1. Well, what I'm going to multiply by here is something so that the numerator is the same as the denominator. So I've got a 5 up here in the numerator, which basically means I need to put a 5 in the denominator. I've got a 7 here in the denominator, which means I have to put a 7 in the numerator. So now, when I multiply that through, 5 times 7 is 35. Over 7 times 5 is 35. But if I multiplied by 7/5 in the denominator, I have to multiply by 7/5 in the numerator. Because you got to do the same thing. Now, granted, I know when we talk about in the numerator denominator, that's a little confusing because I've got fractions within fractions here. But here, I'm just looking down here, numerator times numerator, and I get 35 over 35. That is going to be 1. That's what I wanted to happen. I want the denominator to end up being 1. So I had to multiply it by the reciprocal of that denominator, which means I got to do it up here as well, and then my numerator. So 2 times 7, okay, is going to be 14. 3 times 5 is going to be 15, so this is going to be 14/15 divided by 1. Well, that just becomes 14/15. But it's this little bit here, the act of trying to get rid of that denominator, multiplying by the reciprocal, I end up having to multiply the numerator by the reciprocal as well. I already know that my choice of doing that is going to make the denominator equal to 1. And so simply what I'm left with is this bit up here, really. That's what this division statement becomes. That may or may not have helped. If it helps clarify it for somebody, that's great. If not, if that's kind of confused you, the issue here really is that you get used to the pattern here and how we go about doing this. So let's take a look at some examples, and hopefully after doing this a few times, you'll just make sense of the pattern. So our first one here is 1/9 divided by 5/6. So I already know that I'm going to take that 1/9 and I'm going to convert this into multiplication by reciprocating, okay, that divisor right there. Okay, and it's always, this is what we call the divisor. This is the dividend. First one is the dividend. The second one is the divisor. So we're going to multiply by the reciprocal of the divisor. So we're going to multiply by 6 over 5. We're going to multiply the numerators together. So 1 times 6 over 9 times 5. It's going to be 6 over 45. But I notice when I look at this that those are both multiples of 3. 3 divided by 3 becomes a 1 over 1. Is the same I should say it like this. Maybe I should say it like this. It's the same as 1 over 1. And then this becomes 2 times 1 over 1 times 15, or 2/15. Okay? Here, similar sort of thing. 3/8 is my dividend. I'm going to multiply by the reciprocal of the divisor, so I'm going to multiply by 8/7. Now, this is going to be 3 times 8 over 8 times 7. And right away, I see these common factors here, right? And 8 divided by 8 is the same as 1 divided by 1. 3 times 1 is 3. 1 times 7 is 7. So this becomes 3/7. Here. Oh, boy. These mixed fractions here. So we're going to convert these into improper fractions. Improper fractions are so much easier to work with these operations. So 1 times 3 is 3, plus 2 is 5, so this becomes 5/3. Divided by, okay, I'm going to put parentheses around this simply so that I keep the negative together with it. Okay, so I'm not going to confuse that with it being a subtraction in there. It's a negative number here. So now 2 times 4 is 8, plus 3 is 11. Now that it's written out this way, it's a little bit easier to work with. I'm going to make this 5/3 multiplied by, now I'm going to reciprocate, negative 4 over 11. Now you might look at this and wonder, well, wait a minute, what about that negative there? Where does that negative go? Well, it turns out when you've got a negative in front of a fraction, a negative in the numerator, or a negative in the denominator, you kind of have the freedom to move that negative wherever you want. Okay? So like a negative 2/3 really is the same thing as negative 2 over 3, which is the same thing as 2 over negative 3. I can kind of put that negative wherever I feel like it. So a lot of times we're just going to put it in the numerator, regardless. Now, I know that positive 5 times negative 4 is going to be a negative number. 5 times 4 will be 20. And then in the denominator, I'm going to get 3 times 11, or 33. Now, I'm curious if I can simplify this. But you know what? 3 and 11 are both prime numbers, and neither of the numerator factors here has got a common factor of 3 or 11. So this isn't going to simplify. That's as far as it's going to go. Down here, 2/5 divided by 7/6, so 2/5. We're going to multiply by the reciprocal, so 6/7. And then multiply the numerators together, multiply the denominators together. And even at this point right here, just thinking ahead about the simplifying, I notice that there's no common factors here. Even if I break 6 up into 2 times 3, there's nothing common with the denominator. So when I multiply these out and get 12 over 35, that's as good as it's going to get. I cannot simplify that any further than that. And then here, my dividend is 3/4. I'm going to multiply by the reciprocal of my divisor. So 3 times 8 over 4 times 7. And here, I do notice that I can write 8 as 2 times 4. And so 4 times 7, there is that common factor of 4. 4 divided by 4 is the same as 1 divided by 1. But I'm lazy, and I like working with 1 there. So 3 times 2 is 6, times 1 is 6, and then 1 times 7 is 7. And so that becomes 6/7. Okay, so now we're just going to look at a couple of word problems that deal with the same operations here, okay, multiplication and division. So Nancy created a mixture using 3/4 of a cup of sugar and half a cup of cinnamon to add to some hot apple cider. Okay, so we're putting those two together. If Nancy uses 1/16 of a cup per serving of hot apple cider here, how many people can she serve? Okay. So what we're doing here is we're going to, first of all, she's got this bin here that she's putting the sugar into and the cinnamon into. And then she's going to take this out. So she's putting in 3/4 of a cup of sugar. She's putting in 1/2 a cup of cinnamon. And then she's going to pull out 1/16 of that mixture for every cup that she gives to people. So we want to figure out how many cups. So first of all, we've got to figure out, well, how much is in there? So we're going to have to add those two together, the 3/4 and the 1/2. Then we got to divide that by 1/16 to tell us how many cups this is going to be. Okay? Each cup, or each serving, I should say, probably makes more sense to say it like that. Each serving of apple cider is going to be 1/16 of this. So if I divide it by that size of that serving, I'll know how many servings I've got. Now, I have to do what's inside the parentheses here first. I have to add those two fractions together. Adding requires a common denominator. This is 3/4 plus 1/2. It's not the same thing, right? I could even hear it when I describe those fractions. I'm not adding the same thing. 3/4 plus 1/2. Now, I can turn this into a fraction with the same denominator by simply multiplying the denominator here by 2 and multiplying the numerator by 2. So then I get 3/4 plus 2/4 divided by that 1/16. Okay, well, this is easy to do. Okay? 3/4 plus 2/4 is 5/4 divided by 1/16. So now that I've put together the two fractions within the parentheses, now I can move on and do the division here. And so now what I'm going to do is I'm going to take that 5/4, and I really don't need to write the parentheses anymore here. Okay, I'm going to take that 5/4, and I'm going to turn this into a multiplication by multiplying by the reciprocal 16/1. Now, here we go. 5 times 16 is going to be 80. 4 times 1 is going to be 4. So this ends up being 80 divided by 4. Now it turns out that works out rather nice. That's going to end up being 20. So she can serve 20 people. Okay? Now, let's take a look at this next one. The fuel tank of Andy's car holds 8 3/4 gallons of gas. If Andy's car uses 7/8 of a gallon to get to work in the morning, how many round trips to work and home can he make using the gas argument? So he wants to know, so here's home, here's work. We want to know how many round trips he can make here. But remember, that 7/8 only refers to one direction here. So there's a 7/8 going this way. Now, there are a couple of different ways that we can kind of go about doing this. But maybe what we do is let's just figure out how many trips he can make. And then let's remember that a trip is going to be there and back. Sorry, a trip is just there. A trip is just back here. We want to know how many trips he can make here, but a round trip is going to be there and back. So we're going to do a couple of bits of division here. So first of all, how many trips can he make? Well, we're going to take that 8 3/4 and we're going to divide it by the 7/8 of a gallon that he uses. Now, I'm not particularly fond of that. I want to convert 8 3/4 into a mixed fraction first. Sorry, it is a mixed fraction. I want to convert it out of being a mixed fraction into an improper fraction. So 8 times 4 is 32, plus 3 is 35. So 35/4 divided by 7/8. Now remember, I don't need common denominators when I'm doing this. So I'm going to take that 35/4, I'm going to multiply by 8/7. Oh, and I notice a couple of things. First of all, I notice that 35 is 5 times 7, and 8 is 4 times 2. Now, that's significant, because in the denominator, I'm going to multiply the 4 by the 7. Well, now I've got a 7 in the numerator, 7 in the denominator. 7 over 7 is like exactly the same as 1 over 1. 4 divided by 4 is the same as 1 divided by 1. And so now what I've got up here in the numerator is 5 times 1 times 1 times 2. So 10. And in the denominator, I've just got 1 times 1. So the answer is we can make 10 trips. Now the thing is that a trip is just home to work, work to home. So therefore, and that's what those 3 dots mean, therefore, if I take 10 and divide it by 2, I get 5 round trips. So Andy can make 5 round trips on a tank of gas. Oops, can't see that. Okay. Now there is another way that we could have done that. Okay. I'll just quickly do it over here. What we could have done is we could have realized that because it takes 7/8 of a tank of gas to go this way and 7/8 to go this way, we could add that together to make a round trip. So granted, he starts with 8 3/4, but now we can divide that by 7/8 plus 7/8, and this becomes a round trip worth of gas. Well, we already know 8 3/4 ends up being 35/4. And we're going to divide that. Well, 7/8 plus 7/8 is 14/8. Okay, so now I'm going to multiply that 35 over 4. I'm going to multiply that by the reciprocal. And it might not be abundantly obvious, but again, 35 is going to be 5 times 7. 8 is going to be 4 times 2. And then we get 4 multiplied by, and 14 here is 7 times 2. And so now I've got a lot going on here. The 7 divided by 7 is the same as 1 over 1. 4 divided by 4 is the same as 1 divided by 1. 2 divided by 2 is the same as 1 divided by 1. And so what I'm left with here is 5 times 1 times 1 times 1, which is just 5, over 1 times 1 times 1, which is just 1. And again, the answer is, whoops, 5 trips. Or 5 round trips, we should say. Yeah. There you go.